All right, this is lesson 12.6, segment relationship in circles. All right, so the chord-chord product theorem. So if two chords intersect in the interior of a circle, then the products of the lengths of the segments of the chords are equal. So what it's basically trying to tell you is, if we look at this chord AB, AE times EB will equal the same thing as DE times CE, as you can see over here. So if we multiply each of those segments together in one chord, it will equal the other two segments in the other when they're multiplied. So problem 1, find the value of x and the length of each chord. So given our picture, we are going to apply that theorem where SQ times QT will equal PQ times QR. So we have 6 times 4. We just multiply those two together, where we have 8x equals 24. Divide both sides by 8 to get x by itself, which is simply going to leave us with x equals 3. X equals 3. So now that we know what x is, to find the length of the chords, well, once again, the chords are going to be ST and PR. So ST is x plus 8, and we know x is 3, so plus 8 is 11. And PR is 6 plus 4, which is 10. So you'll notice that the actual lengths of the chords are different, and that's normal. Very often they won't be the same. But when you take the chord and break it up at its intersection point, those two segments, when they multiply, will equal the other chord, those two segments multiplied together. That's why this works. It doesn't mean the length of the chords are the same, so don't make that misconception. So problem 2, once again, we're going to find the value of x and find the length of each chord. So if we look at the chord AB, that means we're going to take this 6 and this 5. They're going to get times together, and they're going to equal DC. So we're going to take the 8 and the x and times that together. So we're going to get 8x, and we're going to get 30. And so when we go ahead and divide both sides by 8, because we want to get x by itself, we will have x equals a decimal of 3.75. Once again, it asks us to find the chords. Now we'll know that AB is simply 6 plus 5, which is 11. And CD is x plus 8, or x is 3.75, plus 8 is going to give us 11.75. Okay, so this is the secant-secant product theorem. And this one basically says that if we have a secant, which is a segment that goes through the circle, hits it in two places, and then you have another one, like CE here, they're going to intersect somewhere sometimes. When they do, what happens is that the length of the entire secant, so A to E, times the exterior part of the secant, B to E, will equal the total length of the other secant, which is CE, times its exterior piece, DE. So they'll equal the same when they're multiplied. So what does that look like in a problem? Well, easier to understand when you see numbers. Okay. Find the value of x and find the length of each secant segment. So our first secant segment is here, RT, marking in purple. And to set up our problem, we're going to start with taking the exterior, which is 4. And that's going to get times to the total length of the secant segment, so RT. So 4 plus 6 is 10. We then have that equal the other segment, secant segment, which is going to be RQ. We're going to take the exterior, which is 5, and that's going to get multiplied to the total length of RQ. And our total length is 5 plus the x. Now our equation's set up for us to solve for x, so now we just do our algebra. We have 4 times 10, which is 40. We distribute our 5, so 5 times 5 and 5 times x, so we get 25 and 5x. We go ahead and solve the equation like we normally would. We want to subtract the 25 over to the 40. And we're going to get 15 equals 5x. Divide both sides by 5. And so x is 3. Now that we know what x is, we can find the secant segments. So RT is 4 plus 6, which we know is 10. And then RQ is 5 plus x, but our x is a 3, which is 8. All right, so problem 4, once again, find the value of x, find each secant segment. So if we look at the secant JG, so this entire secant here, so we have the exterior of it being 13, and then the total length of JG is Z plus 13, and that's going to equal the other secant from L to G. Once again, take the exterior, which is 9. We're going to times it by the whole length, so 30 plus 9 is 39. Now we're going to go ahead and distribute, solve the problem. So we've got 13 times z, that's 13z. 13 times 13 is 169, equals 9 times 39, 351. From there, we just go ahead and solve like you would any other problem, minus the 169 over to get z by itself. So now we have 13z equals 182. Divide both sides by 13. And z is 14. So now we know that z is 14. We can simply find the secants now. So JG should be z, which is 14, plus 13, which is going to be 27. And then LG, which is going to be 30 plus 9, which is 39. All right, so this theorem is the secant tangent product theorem. And so when you have a secant like AC, following what we did in the previous problems, that the total length AC times the exterior part BC will equal, this time it's going to equal, for the tangent line, the exterior of the tangent line right here being squared. So problem 5, find the value of x. So PQ, this is our tangent line. This is the one that gets squared. SQ right here is the one where we take the exterior, which is 4, times it by the total length, so 5 plus 4 is 9, and that's going to equal the tangent part, which is PQ, being squared. So we have x squared. Now we just go ahead and solve. We have 4 times 9, which is 36, equals x squared. But we want to find out what x is, not what x squared is. So we can square root both sides to get x by itself. And so now we have x equals plus and minus 6. However, we're talking about length, and we can't have negative length. So in reality, x is simply the positive 6. All right, so for problem 6, find the value of x. So once again, we want to make sure we identify our tangent. Our tangent is going to be dg here, and that's the one that's going to get squared. Our secant is df, that's this one in purple, where we take the exterior part 7, and we times it by its total length of the secant, which is 7 plus y, and that's going to equal our tangent, which is 10, and then that one should get squared. We just go ahead and we follow our algebra. 7 times 7 is 49. 7 times y is 7y. 10 squared is 100. Subtract 49 over to the other side to get y by itself. And we have 7y equals 51. Divide both sides by 7, and y is 7.3 when rounded to the nearest tenth.